Hi, I'm Mihai, CTO for Cloud Native Era Solutions at IBM. And here with me, I have today Elif Samedin, DevOps engineer at the Web. We're going to talk about building CI/CD pipelines using Packer, Vault, and Terraform. First, we're going to take a look at what exactly are we going to automate. So we're going to show how an image is built by hand, and then we're going to use Packer, Vault, Ansible, Terraform, Vagrant, and other tools to put all of this together into a workflow which can build and import images onto AWS, and can also be used to build and import images onto other cloud providers or hyperscalers or virtual environments. So let's get started. My background is in DevOps and DevOps engineering. I used to run and build a very, very horrible Perl-based platform, kind of similar to Packer, around 2010, and found the process to be quite painful and challenging. Thanks to Packer, Terraform, and Vault, this process has become a lot easier. Building and maintaining images for multiple platforms has become quite easy. Elif, I know that you use a lot of HashiCorp tools in your day-to-day work. A couple of words about yourself and your experience as well with the HashiCorp product suite.
Hi, Mihai. Thank you for the introduction. Hi, everyone. I'm Alif. I have been using HashiCorp tools for quite some time. I have started using Terraform for about a year within the company I'm currently working for. And afterwards, I started diving more into what Packer has to offer, as well as Vault. I also had a presentation in Romania about developing a backup and recovery solution, leveraging what Vault has to offer. And hopefully I'm going to discover more and more what these technologies offer to us.
Hey, excellent. And if you're looking for another session later on, you should check out Elif's session. She's holding a session specific to Vault as well in this series. So let's take a look at the potential workflow for building environments for, an image environment for immutable images with Packer. So we're going to store all artifacts in Git or some other kind of version control repository. And any code change will trigger a CI/CD process that starts a new build. Terraform can build a build node. Why would you want to have that, using up resources unless you're doing an image build? And then on this build node, we can generate parallel builds based on a base OS image. So let's say I'm going to, make an enterprise build, RHEL 7, 8, Windows, Fedora, whatever I want to build with Packer. And I'm going to target KVM, VMware, VirtualBox. I'm going to build environments for Vagrant, so I can give developers local VM environments as well. Now, once I have this base OS image layer, I can create customized versions of this image. So instead of starting again from the ISO, right, base OS build, I can start from the pre-existing image. Kind of like Docker or container source to work where you have that layering process. So here, for example, I'm going to use OpenSCAP. If you're not familiar with OpenSCAP, it's kind of like a security profiler. I can say I want this image to be PCI compliant or HIPAA compliant or apply a compliance and security policy on top of it, and it will generate Ansible or shell remediation to take my image to that compliance level. And then I can now trigger my third build based on the same build. And I can now install my middleware. I can install my databases, my applications, and then I can package, sign, and upload my images ready to be provisioned and ready to be tested. I can also use Terraform now to automate the provisioning and testing process. I can do it in a development environment. I've taken the images I've imported into my cloud provider or my VMware catalog or KVM image repository. I can run a couple of tests. And once I'm certain everything is good to go, I can release those images onto production. And I can build new environments based on these images again with Terraform. A couple of things to consider when approaching the build like this. I can definitely build a single image. So I can use the QEMU builder, and then I can convert it. QEMU EMG, convert to raw to VMDK, or using VirtualBox, I can convert it to a OVA file, and then I can upload it to AWS. I can upload it to various hypervisors. I can also use the different Packer build options to build specific images. So I can use one of the 4 AWS builders to build my image directly on AWS, starting from an AWS image. So there's an architectural decision for you to consider. Also, you need to consider where you're building these images. So if you're converting them to a raw image and uploading them to AWS, that's going to take up a lot of space. So there's a trade-off there. And if it takes up a lot of space, it also takes up a lot of time in transit as you upload it onto S3. So maybe it's better to package my image as an OVA or a VMDK, which is a compressed file format, and it will end up taking less space, even though the build process is going to be a bit more complex, and I might have to use more than one builder. So again, there's a couple of trade-offs there to consider. You also want to consider the supported kernel and VM tools of each of the cloud providers. So, AWS, and if I'm using, VMware tools, and QEMU tools, OpenVM tools. As I'm building these images, maybe I'm going to trigger an Ansible playbook, which will detect the environment I'm building the image for, and it will install the appropriate tools. Other things to consider is, what do I want to bake into the image versus what I want to trigger as a post-deployment step. So what exactly are we automating? Let's build an image by hand. So let's say we want to build a CentOS image or RHEL image, and we're going to do it with KVM. Do we want to use Kickstart, or do we want to script some steps manually? Do we want to build a clean image, or do we want to convert it? What goes into the post-provisioning script versus what goes into Cloud Init versus what goes into the image itself? If you're doing this with Kickstart, you've probably used tools like virt install with KVM to trigger the Kickstart configuration and automate the installation process, then enable things like the various VMware or QEMU guest agent or AWS tools if you want to install those after the image is built and later imported onto AWS. OpenSCAP is the profiler I've mentioned before that can be used to secure your image. And as you can see, it kind of generates a list of remediations against the baseline. So if you scan an image against, here's the secure configuration policy, it will show the deviations, and then it will help you automate the remediation process. So you can figure out when you want to bake in this step, and it kind of matters when you bake it in as well, right? So think about it. Let's say that you're building an image with middleware on top. Do I do the remediation before or after I configure my middleware? And will that affect the security report? Will it open additional ports? Will it change the configuration on the image? So as you're putting together all these bits and pieces, you need to orchestrate them in the right order for you to get the optimal results. And one of the cool things about OpenSCAP is that it can also generate automated remediation snippets with Ansible. And as you know, Terraform and Packer can trigger, or even Vagrant can trigger Ansible as well. So for example, if I'm building a development environment with Vagrant, I can say, hey, when you're done provisioning this, I want you to trigger this Ansible playbook. If I'm building an OS image with Packer, I can do it, and I can bake it in to the image, preferably before I even do the image cleanup step. Delete history so folks don't see how the image was built. Fill up the image with zeros, like create a large file so every file gets deleted so folks can't undelete things or secrets you might have left on the image and so on. So once we have OpenSCAP installed and ready, and we have the image and we understand how to build this manually, we're going to look at automating this. And we're going to have a demo, and we're going to show you how all of this works in building a AWS image as well. So Packer starts with a specification here. HCL2 is also supported now, not just JSON. And you can create a specification where you have your builder, you have your communicator, your provisioner, and your processor steps. So think about it like this. In your specification, you say that the image is going to be built using QEMU or AWS builders, and then Packer is going to connect to it using SSH, is going to kickstart the image by literally typing in the commands. If it's using QEMU, it's like typing in the Kickstart command, or if it's using AWS, specific methods, then it's going to trigger one of the provisioners. It can be as simple as a shell script, can be as complex as something like Ansible, where you're going to install your application or perform various configurations and clean up steps. And once the image is ready, you can post-process it, create a Vagrant box file, archive it, create a checksum, package it in some form. You can even create, say, image for KubeVirt and upload it to a container registry, and it's still a virtual machine image. When it comes to building images for AWS, we have options. This may not necessarily be the easiest choice here, because there's a couple of trade-offs to consider. But for me, the ones that I found the most compelling are Amazon EBS and the QEMU Packer Builder. So QEMU Packer Builder allows me to build images for all cloud providers and hyperscalers and everything else, and then convert them. One image, I build everything up, I install the middleware, then I convert it to the various providers. I maybe run a couple of remediation steps on top of it to install additional things on the image if I have to, and I have some tools which allow me to make those steps quite painless. And then I can import them, for example, using the import-export framework to get them on AWS or whatever cloud provider. Amazon EBS can create AMIs from a source AMI. Downside is this needs to exist, right? So you're going to take a CentOS or an Ubuntu or whatever else at whatever price is offered by Amazon, and you're going to build starting from that image. And then there's some variations of that. Last one, EBS surrogate, is kind of like the from scratch Docker concept, right? If you want to build Solaris, Open Indiana, Open Solaris, FreeBSD on Amazon, this would be the way to go. They all use various tricks of mounting volumes in certain ways and giving you access to them and building images on top of those. But we're going to look at EBS and QEMU Builder in this session. So let's talk about secrets as well, because it's important to know that all these tools, Terraform and Packer and so on, can interact with HashiCorp Vault, where you can keep your keys and keep everything secure as well. So Elif, would you like us to just give us a flavor of what's going to be in your more detailed Vault session here as well?
Thank you. I will, but let me start with the question, Mihai. How do you protect? Where do you keep your passwords actually?
Oh, it's a sticky note right here.
Oh my! I cannot believe that. I hope to persuade you to have a Vault instance in order to have, or maybe a Vault cluster. Who knows? At the
You
end
haven't
of
seen
the
my
session,
handwriting though, so I think that protects me from a lot of the attacks, right? But let's hear it.
however, what happens in case you forget it?
My handwriting, yeah. I don't understand it either. Good point. Let's take a look at Vault.
Indeed. So, what is actually Vault? In a nutshell, it is a secrets and encryption management system. It secures, stores, and tightly controls access to tokens, passwords, certificates, encryption keys. In short, anything that is a secret, meaning sensitive data. There are several advantages to using Vault. Among these, I would name that Vault is a centralizing identity. Currently, many organizations are going to take advantage of multiple public clouds, AWS, Azure, Google Cloud. Consuming services on each of these means that organizations need to manage services, to manage actually the identities separately. And at some point, this might become cumbersome. This scenario is an area where Vault shines because Vault supports most of the major cloud platforms out of the box, along with critical services commonly found on premises, such as LDAP. Organizations can now centralize identity requests to Vault, directing all applications requiring service access to Vault rather than individual provider themselves. Moreover, Vault provides consolidated secrets management for the entire organization. And in order to ensure that a person is allowed to have access to certain data, there are policies which we should have in place, and we are able to define this. So the principle of the least privileged is followed. Also, there are some dynamic credentials, such as AWS Dynamic Secrets Engine. I'll not provide so many details about this. However, in a nutshell, this would be about Vault.
Hey, that's excellent. And we know that you can also use Vault in combination with Terraform, and you can provision things with Terraform. What's your experience on this this area of, combining Vault, Terraform, or just using it for provisioning various infrastructure?
Well, there are various approaches in using Terraform in relation to Vault. For example, I could provision resources in either cloud, and then use some configuration management tools such as Ansible in order to get a Vault cluster. On the other hand, we could use Packer, as you have pointed out previously, Mihai, in order to get a Vault golden image, and then use Terraform using this golden image to provision our cluster. In the second approach, we would also touch the concept of immutable infrastructure, because we start with something and then use an infrastructure as a code tool and get the result. We could tear the cluster down, Terraform apply, and we'll get the same result. Well, be careful with the backend configured for Vault. I highly suggest you to have a backup of it.
Fair enough, fair enough. And we also know we have Vagrant, which can be used to build and test environments, local environments, and push them onto Vagrant Cloud. Let's take a look at the demo for these things. Elif, and you can tell us more about Vagrant as we get the demo started. In the meantime, I want to redirect the audience to our Twitter handles at Criveti, Mihai, and Mosessohn-Samedin. Some of our other talks are on github.com, Cube talks, and feel free to connect with us on LinkedIn, Twitter, and whatever else. Let's take a look at the demo itself. So we're going to use Packer with Amazon EBS first. So here you can see we're setting up a couple of variables for our access key. So we're going to give it access to our AWS account. Hopefully that's not your root key. And then we're going to create a source for Amazon EBS, where we're going to give it a source AMI. So hopefully we're going to use an AMI which we like, and we're going to build based on this AMI. And once we run Packer build, and of course we have the secrets in place, what you'll see here is that we have a successful build. It takes a couple of minutes, and a new image is available. Now, the new image is going to be the same as the old image unless we add some of those provisioners, an Ansible, a shell script, something to run against it and make some changes, and then repackage it again as a new AMI. Of course, we can test it, and we're going to use Terraform here. Like Elif was presenting, we're going to use a provider for AWS. We're going to pick a region. Of course, all this should go into your variables for configuration, or Vault if you're using secrets and other places to store your configuration. And we're going to provision a server. In fact, we've actually packaged Vault as an image we're going to use here. Just as an example, we wanted something to install. We're going to give it an instance type of T2 micro on a free account and see how that gets provisioned. And of course, don't forget to allow SSH in, otherwise you're going to be knocking on that door for a while until you figure out, hey, it's blocked. We're going to give it a key. We're going to output the public IP, so Terraform can also output things. So here, for example, you can output the public IP so we know what we're connecting to. Init, plan, apply, and there we go. And then we can also destroy the resources and clean things up. Just a couple of cool tools, Terraform output, Vault IP can output the IP because it's one of the output variables, and we can also SSH into the image and use this magic IP to get instance information from Amazon. So moving on, let's take a look at a more complex build using QEMU builder. And this approach is basically using a QEMU builder with a bunch of scripts to do the provisioning steps with Ansible as a provisioner, and then a number of post-processors. So here, for example, we're using QEMU to convert the QCOW to a raw image, and we're also creating a box image, compressed box image using a Vagrant post-processor. This is fairly useful because we can build the image. It will, build the QCOW, and then it will run the various post-processors against it. And of course, once we have the image ready, we can install Vagrant. Here I'm installing with the Livert plugin because I like to use KVM myself. And as Elif was describing, we can build single boxes or multiple boxes and other complex configuration based on this. Anything else with Boxster, Elif, with Vagrant?
About Vagrant, I think it's quite cool. It eases up the development time. It increases speed. Developers, I think, are now able to perform checks to validate some piece of code much quicker, for example, as you did now. What alternative would have been to Vagrant up to this moment? I think it's simply unique in the industry.
Yeah, and if you're using something like, even with systemd containers, it can be very, very complicated to fully emulate an environment. So, I can even set up a Kubernetes environment in Vagrant. I can run it with multiple instances, and I can do my work there and, orchestrate it as needed, upload all of those boxes in place. And it's very easy for developers to get started with, it's one command, Vagrant up, and we're pretty much ready to go for a full environment.
The learning curve is quite fast. That's, I think, what makes it great.
All right. And last but not least, we have all of this stuff in place. We're just going to dump it onto an AWS S3. We have our raw image, our VMDK, and we're going to create a policy file on AWS so we can use the import-export API, create a bucket, and we're going to load the image onto this bucket. Once the image is uploaded in place, we're going to create another policy to allow the import-export API to access it. And then we're going to import the image from S3. And there, once we have it in place, we're able to use it. So as you can see here, here's the CentOS image I built with Packer locally, and I've uploaded onto AWS, and I can use it there. That concludes our demo. This has been Mihai and Elif. Please reach out to us on Twitter, LinkedIn for questions and more. And looking forward to more sessions and great content from HashiCorp. Bye-bye.
Thank you, everyone.